Students, welcome to Alphores e-learning botany classes. In today's session, that is session 13, we are going to discuss about parts of a leaf. What it is? Parts of a leaf. The three main parts of a leaf, are: number 1, leaf base; number 2, petiole; number 3, leaf lamina. Okay, the three main parts of a leaf. Three main parts of a leaf are: first one is a leaf base. What is the first one? Leaf base. Second one is a petiole. What is the second one? Petiole. Third one is a leaf lamina. What it is? Leaf lamina. Okay, these are three main parts of a leaf. Okay, what is the first one, sir? Leaf base. Leaf base is also called as a hypopodium. What it is called as a hypopodium. Hypo means below. Yes or no? Petiole. Petiole is also called as a mesopodium. What it is called as? Mesopodium. Sir, leaf lamina is also called as a leaf blade. What it is called as? Leaf blade. It is also called as a epipodium. Epipodium. Okay, therefore leaf base, hypopodium, right? Petiole, mesopodium, right? Leaf lamina, also called leaf blade or epipodium. Okay, if you see the diagram, sir, in the diagram, this is the leaf base. What it is, sir? Leaf base. What is this? Petiole. This is a petiole. Okay, whereas this part is called as a leaf lamina. This is the leaf lamina. Okay, go for the first one. What's a leaf base? Go for leaf base. Name itself indicates, see, base of the leaf. Sir, this is the leaf base, right? The base of the leaf by which leaf is attached to the node of the stem. What is attached? Right? Leaf is attached to what? Node of the stem with the help of what? Leaf base. Therefore, base of the leaf by which leaf is attached to the node of the stem, that base of the leaf is called as a leaf base. Okay. Sir, in case of monocots, grasses, dicots or monocots? Monocots. In case of monocots, sheathing leaf base is present. In case of monocots, what is present? Sheathing leaf base is present. In case of which plants, sir? Monocots. In case of monocots, what is present? Sheathing leaf base is present. What is the meaning of a sheathing leaf base, sir? This leaf base is like a layer. Leaf base is like a layer, like a sheath, and covers the stem either completely or partly. What is sheath like? Leaf base is sheath like. That leaf base which is sheath like covers the stem either completely or partly. That leaf base is called as a sheathing leaf base, present in the case of monocots. Sir, in case of some legume plants, this leaf base is pulvinous. What is pulvinous? The leaf base is pulvinous. What is pulvinous, sir? The leaf base, it is pulvinous in case of some legume plants. That pulvinous means nothing but bulged. swollen. Therefore, swollen leaf base or bulged leaf base is called as a pulvinous leaf base. What it is called as a pulvinous leaf base. Pulvinous leaf base. Pulvinous leaf base means nothing but what's a swollen leaf base, bulged leaf base. Seen in the case of some legume plants, Fabaceae family plants. Okay, now listen the statement. So I am saying this one as a what's a leaf base, right? On either side of leaf base, I am saying on either side of leaf base, two small green leaf-like structures are present. How many? Two. What is the size? Small. Color? Green. Where they are present? Either side of leaf base. These two small green leaf-like structures are called as stipules. Sir, stipules are associated with root, stem or leaf. Stipules are associated with a leaf. Stipules are not associated with root, not associated with stem. They are associated with leaf. Therefore, stipules are associated with which vegetative organs are? Leaf. Two small green leaf-like structures present on either side of leaf base called as stipules. Sir, if a leaf is with stipules, see this diagram? Sir, in this diagram, the leaf is with stipules, yes or no? Leaf with stipules, stipulate leaf. Leaf without stipules, exstipulate leaves. Okay, therefore, sir, if a leaf is with stipules, leaf with stipules, if a leaf is with stipules, that leaf is called as what's a stipulate leaf. What it is called as a stipulate leaf. Stipulate leaf. Sir, if leaf is without stipules, sir, leaf right without stipule, leaf is without stipules, then that leaves are called as exstipulate leaves. What are such leaves called as exstipulate leaf? Is it okay? Therefore, leaf with stipule, what we should call as stipulate leaf. Sir, most of the dicot leaves are stipulate leaves. Most of the dicot leaves are stipulate leaves. Most of the dicot leaves. Most of the dicot leaves are stipulate leaves. Sir, if a leaf is without stipules, leaf is without stipules, then what is that leaf called as exstipulate leaf? Most of the monocot leaves are exstipulate leaves. Most of the which leaves, sir? Monocot leaves. Most of the monocot leaves are exstipulate leaves. Okay, in taxonomy chapter, right, in the first year itself, in the taxonomy chapter, we are going to discuss about Fabaceae, Solanaceae and Liliaceae families in detail. Okay, that's why I am saying right about these three families also. Okay, Fabaceae, Solanaceae and what's are Liliaceae. Okay, now listen here. So take a Fabaceae family. Which family? Fabaceae family. Fabaceae. Sir, Fabaceae is a dicot family. What it is? It's a dicot family. It's a dicot family. Most of the dicot leaves are stipulate. Sir, Fabaceae, stipulate leaves are present. What are present? Stipulate leaves are present. Stipulate leaves are present in Fabaceae family. Okay. Now you take a Solanaceae family. Which family? Solanaceae family. Solanaceae family. No doubt Solanaceae is a dicot family. But in case of Solanaceae family, leaves are exstipulate. Leaves are exstipulate. Exstipulate leaves are present. Now you take the third family. What it is? Liliaceae family. Liliaceae family. Liliaceae family. Sir, Liliaceae, it's a monocot family. Liliaceae, it's a dicot or monocot, sir? It's a monocot family. Right, in Liliaceae family, which condition is present? Exstipulate condition is present. What is present? Exstipulate condition is present. Fabaceae, stipulate leaves. Solanaceae exstipulate leaves, Liliaceae exstipulate leaves. Okay. Now we are discussing, right, stipules, right? Go for foliaceous stipules. What's that? Foliaceous stipules. Foliaceous stipules. Foliaceous stipules. Photosynthetic stipules are called as foliaceous stipules. Photosynthetic stipules. What? Photosynthetic stipules. Photosynthetic stipules are called as foliaceous stipules. Sir, foliaceous stipules example. I am writing the example. Number 1, pisum. Pisum. Second one is lathyrus. What and what, sir? Pisum and lathyrus. These two are examples for foliaceous stipules. Okay, right. Now go for the second part, the second main part of a leaf. What it is, sir? What is the second part? Petiole, right? Petiole. Mesopodium. Mesopodium, right? Now see, sir, this is the leaf, right? This is the leaf. The stalk of the leaf is called as a petiole. Stalk of leaf or stalk of a flower? Stalk of leaf is called as a petiole. Now see this leaf. Sir, this leaf is with petiole. Leaf with petiole. Petiolate leaf. Petiolate leaf. Sir, if leaf is without petiole, it is a sessile leaf. It is a sessile leaf. Sessile leaf. Most of the monocots, and in case of Calotropis, leaf is sessile. Leaf is sessile, means petiole is absent. Okay. Therefore, what is the meaning of petiole, sir? Petiole means nothing but a stalk of leaf. Stalk of a leaf. Okay, right. Sir, leaf with petiole. Leaf with petiole. What we should call that leaf? Petiolate leaf. Petiolate leaf. Okay. Sir, if leaf is without petiole, leaf is without petiole, then that leaf is called as a what, sir? Sessile leaf. That leaf is called as a sessile leaf. Therefore, petiolate leaf, it is with what? Petiole. Whereas a sessile leaf, it is without petiole. It is without petiole. So, sessile leaf examples I am writing. Sessile leaf examples. Most of the monocots. What, sir? Most of the monocots. Sir, even this sessile leaf is seen in the case of a Calotropis plant. Calotropis plant. What is the common name of Calotropis plant? Milkweed. What is the common name of Calotropis plant? Milkweed. Milkweed. Okay. Now listen this statement. Sir, this is lamina. Yes or no? Sir, this petiole bears the weight of the lamina. Who is bearing the weight of the lamina? This petiole. Petiole bears the weight of the lamina. This petiole exposes the lamina to the sunlight. Petiole, it is bearing the weight of the lamina. At the same time, it is exposing the lamina to the sunlight. Who, sir? Petiole. Okay. Therefore, petiole bears the weight of lamina. Bears what, sir? Weight. Bears weight of lamina. And exposes. And exposes what? Lamina. Exposes lamina to sunlight. Exposes lamina to what, sir? Sunlight. Therefore, petiole, it is bearing the weight of the lamina and exposing the right lamina to the sunlight. Okay. Sir, we are discussing petiole, right? Sir, if this petiole is long, thin and flexible, if a petiole is long, thin and flexible, then lamina flatters. lamina flatters, means moves front and back, side by side. Sir, as lamina flatters in the wind, okay, it brings fresh air onto the lamina. Fresh air onto the lamina. Sir, cools the leaf surface. Cools the leaf surface. If petiole is a long, thin and flexible, long, thin, flexible petiole helps the lamina to flatter in the air, okay, which gives a cooling effect to the leaf, okay, and brings fresh air onto the surface of the leaf lamina. Brings fresh air onto the surface of the leaf lamina. Okay, right? Right. Now go for the third part. What's our leaf lamina or leaf blade or epipodium? Now see this leaf here. Sir, this green expanded portion of a leaf is called as a leaf lamina. Green expanded portion of leaf is called as a lamina. Okay. Sir, we are saying that leaf performs photosynthesis. Leaf performs photosynthesis. But this leaf is having three main parts. In these three, who performs photosynthesis? Leaf lamina performs photosynthesis. Leaf lamina performs what? Photosynthesis. Performs photosynthesis. Sir, this is a petiole, right? This petiole itself extends into the leaf lamina in the form of midrib or midvein. Okay, this petiole itself extends into the leaf lamina in the form of midrib or in the form of midvein, dividing the lamina into two equal halves. Who is dividing the lamina into the two equal halves? This midrib or midvein. Nothing but extension of what's our petiole. Okay, therefore this petiole extends into the leaf lamina in the form of midrib or midvein, dividing the lamina into two equal halves. Dividing the lamina into the two equal halves. Okay, right? Therefore, sir, leaf lamina, what it is? It is the green expanded portion. Green expanded portion of a leaf. Okay, right. Sir, performs photosynthesis. Performs what? Photosynthesis. Performs photosynthesis. Okay, petiole. What it is? Petiole extends. Petiole extends into leaf lamina. Petiole extends into leaf lamina, dividing lamina into two equal halves. Dividing the lamina into two equal halves. Is it okay? Right? Sir, petiole extends into leaf lamina, dividing the lamina into two equal halves. Now, sir, this extension of petiole, what we are calling this extension of petiole as in the leaf lamina? Midrib. It is also called as a midvein. Midrib or midvein. Sir, what does this midrib or midvein means, sir? Nothing but vesicular tissues. Vesicular tissues means what? Xylem and phloem. It means in the leaf lamina, vesicular tissues, that is xylem and phloem, are present in the form of veins. Are present in the form of what, sir? Veins. Okay. Therefore, sir, what is midrib? Midrib, also called as a midvein. Midrib also called as what? Midvein. Okay, right. Sir, vesicular tissues. Which tissues? Vesicular tissues are present. Vesicular tissues are present in leaf lamina. Are present in leaf lamina as what's their veins. Present as veins. Vesicular tissues means what and what? Xylem and phloem. Therefore, in the leaf lamina, this xylem and phloem are present in the form of what, sir? Veins. Once you see this diagram, sir, this is midvein, sir. These are lateral veins. These are lateral veins. This lateral veins in turn produces veinlets. This lateral veins in turn produces what? Veinlets. Therefore, this is a midvein. Okay, these are lateral veins, whereas these are veinlets. Okay, arrangement of these veins and veinlets in the lamina of the leaf is called as a venation. What is the meaning of venation or venation? Arrangement of veins and veinlets in the lamina of the leaf. In the lamina of the leaf, how these veins and veinlets are arranged? What is it called as a venation or venation? Okay, therefore arrangement of veins and veinlets in the lamina of a leaf is called as what, sir? Venation. Most of the dicot leaves shows reticulate venation. Most of the monocot leaves shows parallel venation. Most of the dicot leaves shows reticulate venation. Most of the monocot leaves shows a parallel venation. Parallel venation. Okay, we are having this venation topic separately. There we will discuss it in detail. Okay, right. Now see here, sir, we are discussing about midrib and midveins. Okay. Now what this midrib, midveins do, sir? Sir, this is lamina of the leaf, right? This midrib, midveins gives rigidity to the lamina of the leaf. Gives rigidity to the lamina of the leaf. Sir, this midrib and midveins, okay, they provides a specific shape to the lamina of the leaf. Providing specific shape to the lamina of the leaf. Okay, sir, these veins, they acts as a skeletal system of the leaf lamina. Acts as a skeletal system of the leaf lamina, supporting the leaf lamina. Okay, therefore, what are the functions of these veins, sir? Number one, gives rigidity to the leaf lamina. Rigidity to the leaf lamina. Okay, number two, second function of veins, what? Acts as a skeletal system for the leaf lamina, supporting the leaf lamina. Supporting the leaf lamina. Number three, gives shape to the leaf lamina. Gives shape to the leaf lamina. Number four, sir, veins means nothing but vesicular tissues, that is xylem and phloem. It means this veins helps in conduction of water, minerals and food materials. Veins helps in conduction of water, minerals and food materials. Okay. Right, we are discussing functions of veins, right? Functions of veins, right? Go for the first one, number one, first one, right? Provides what? Rigidity to leaf lamina. Who is providing rigidity to the leaf lamina? Veins. Number two, veins acts as a skeletal system. Acts as a skeletal system, right, for leaf lamina. Number three, gives specific shape to lamina of the leaf. Shape, specific shape to the lamina of the leaf. Number four, helps in conduction. Helps in conduction of what? Helps in conduction of water, minerals and food materials. Sir, how this veins helps in conduction of water, minerals and food materials, sir? Veins means vesicular tissues. Fascicular tissues means nothing but xylem and phloem. Xylem helps in conduction of water and minerals, whereas a phloem helps in conduction of food materials. Just now I told, right, this veins nothing but what? Xylem and phloem. What's sir? Xylem and phloem. Sir, xylem helps in conduction of water and minerals. Yes or no? Right. Whereas this phloem helps in conduction of what? Food materials. Phloem helps in conduction of food materials. If you take a plant, right, this is stem, whereas this is a root. What it is? A root. This root absorbs water and minerals from the soil. The water and minerals absorbed by the root from the soil, they move to the stem through xylem. From stem, this water and minerals enters into the leaf lamina through midrib. Once this water and minerals enters into the midrib, from midrib they goes to the lateral veins. From lateral veins they goes to the veinlets, by which this water and minerals distributed throughout the leaf lamina. Therefore, these veins they are helping in conduction of, they are used in the conduction of used in the conduction of water and minerals. Conduction of water and minerals. Now, sir, this is leaf lamina, right? This leaf lamina performs photosynthesis. By photosynthesis process, it synthesizes food materials. This food material synthesized by the leaf lamina is collected by these veins. Once the food collected by the veins, this veins takes the food into the petiole. Now this petiole having what? Phloem. That phloem present in the petiole takes the food to the stem. From stem, right, this food moves to the root. It means the veins present in the leaf lamina also helps in conduction of food materials, Therefore, right, this veins helps in conduction of water, minerals and food materials. These are some functions performed by what, sir? Veins, right? Now listen here. Sir, this is a leaf apex. What it is? A leaf apex. This is a leaf margin. What is this one? Leaf margin. Sir, each and every leaf is having a specific shape. Yes or no? Right? Therefore, shape of the leaf, okay, leaf margin or lamina margin, leaf apex, and the extent of incision. Incision means cut. Varies from leaf to leaf. Therefore, what varies from leaf to leaf? Number one, shape of the leaf. What it is? Shape of the leaf. Okay. Number two, leaf margin. Okay. Next one is leaf apex. What it is? Leaf apex. Next one is extent of incision. Incision means what, sir? Cut. Therefore, sir, shape of the leaf, leaf margin, leaf apex, extent of incision, they varies from one leaf to another type of leaf. Okay, this is shape of the leaf, leaf margin, leaf apex and extent of incision varies. Okay, in the nature, that is from outside environment, we can observe different types of leaves. Okay, if you see the shape of the leaf, that differs from one type of leaf to another type of leaf. Similarly, the margin of the leaf, the apex of the leaf and the incision extent of incision, they also differs from one type of leaf to another type of leaf. Okay, this is concerned to write parts of a leaf. Okay, right? Stay home.